Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals, More Examples. In this presentation, we will be solving problems related to indefinite integrals. So let us look at an example which involves an algebraic function. Let's evaluate this indefinite integral 5x times x squared minus 8 dx. So when we have a function of this kind, we want to expand and then be able to expand this given function and then be able to apply the process of integration. So how do we do that? So we write 5x times x squared minus 8. We're going to distribute this 5x to every one of the terms inside the parenthesis. 5x times x squared is 5x cubed. 5x times minus 8 is minus 40x. 5 times 8 is 40x. And therefore, we can write the given function as y is equal to integral 5x cubed minus 40x dx. Now, we can integrate each one of the terms separately, like as shown here. Integral 5x cubed dx minus integral 40x dx. Since we have some constant terms, we can take them outside of the integration process. So therefore, we can write that as 5 integral x cubed dx minus 40 integral x dx. Now we are ready to apply the integration process. Integrating each function separately, we have 5 integral x cubed dx. We're going to use the power rule, and let's go back and then see what the power rule states. If y is equal to integral x to the power of n dx, then the power rule is stating that we're going to take the base term, we're going to take the exponential, whatever power we have, n in this case, we're going to add 1 to that, x to the power of n plus 1 divided by n plus 1. That's what the power rule is stating. So let's go back to our example. So in our case, we have integral x cubed dx. For us, n is equal to 3. So therefore, x to the power of 3 plus 1, the whole thing divided by 3 plus 1, minus 40 times integral x dx. So x to the power of 1 plus 1 divided by 1 plus 1 plus c, which is a constant of integration. So when we simplify this some more, we have 5x to the power of 3 plus 1 translates to x to the power of 4 divided by 3 plus 1 in the denominator translates to 4 minus 40 times x to the power of 1 plus 1 is equal to x to the power of 2 divided by, in the denominator we have 1 plus 1 which is equal to 2 plus c. So now we can simplify this some more and write it as 5 over 4 x to the power of 4 minus 20 because 40 divided by 2 simplifies to 20 x to the power of 2 plus c, where c is a constant of integration. So when we have algebraic functions of this kind, we want to first be able to expand the terms and then simplify them as much as possible, and then apply the integration process to each one of the terms, and then apply the integration process, and then be able to apply the power rules or the basic rules of integration, and then be able to arrive at the final answer. So let's look at another example. In this example, let's evaluate this indefinite integral x squared times x to the power of 4 plus 4x plus 3 dx. So we have a trinomial multiplied to a monomial. So we can expand this x squared times x to the power of 4 plus 4x plus 3 as follows. We're going to distribute x squared to every one of the terms inside the parenthesis. X squared times x to the power of 4 is equal to x to the power of 6. We are using the exponential rules where it says when the bases are the same, we're going to add the powers. We're going to write the base ones and then add the powers. 2 plus 4 is equal to 6. Then we're going to distribute x squared to 4x. So 4 times x to the power of 3, and then x squared times 3 is equal to 3x squared. So we have successfully expanded the function, And now we can rewrite the given function as y is equal to integral x to the power of 6 plus 4x cubed plus 3x squared dx. Now we can integrate each one of the terms separately as shown here. Integral x to the power of 6 dx plus integral 4x cubed dx plus integral 3x squared dx. So since we have some constant terms, we're going to pull them outside of the integration process. In the first term, we don't have any constant, so integral x to the power of 6 dx. Plus, in the second term, we have a 4 as a constant. We're going to take that outside of the integration process for integral x cubed dx. Plus, in the third term, 3 is a constant, so we're going to take that outside of the integration process, 3 integral x squared dx. So integrating each function separately, we can write this as follows. Integral x to the power of 6 dx, we're going to apply the power rule, and let's recap the power rule one more time. If y is equal to integral x to the power of n dx, then we can, using the power rule, we can write this one as x to the power of n plus 1 divided by n plus 1. So let's go back to our example. So integral x to the power of 6 dx can be written as x to the power of 6 plus 1, the whole thing divided by 6 plus 1. In our case, n is equal to 6 here, plus 4 times the second term, integral x cubed dx translates to x to the power of 3 plus 1 divided by 3 plus 1. In this case, the n is equal to 3 here, and then plus 3 times x to the power of 2 dx translates to x to the power of 2 plus 1 divided by 2 plus 1 plus c. In this case, n is equal to 2. So now we can simplify this. X to the power of 6 plus 1 translates to x to the power of 7 divided by 6 plus 1 is equal to 7, plus 4 times x to the power of 3 plus 1 translates to x to the power of 4 divided by 3 plus 1 is equal to 4, plus 3 times x to the power of 2 plus 1 translates to x to the power of 3 divided by 2 plus 1 is equal to 3, plus c, which is a constant of integration. So when we simplify this some more, we can write it as x to the power of 7 divided by 7 plus 4 and 4 cancels out, we are left with x to the power of 4, plus 3 and 3 cancels out, we are left with x to the power of 3 plus c, where c is a constant of integration. So when we have algebraic functions of this kind, and if it is a little bit of involved process, we're going to simplify that process and make it as individual terms, and then apply the integration process, and then apply the rules of integration, and then arrive at the answer. So this is how we're going to solve indefinite integral problems involving algebraic functions. In my next video presentation, we will be solving more examples involving indefinite integrals.